from here to that big tall tank, that's our anaerobic, or UASB, it's an upflow anaerobic sludge blanket. So the wastewater comes up from the bottom and flows up, and that keeps all the microorganisms in suspension. So we don't have to have, mixers in place. It's a more passive, energy efficient system. And then biogas is generated in this tank, and it rises to the top, and that's where it's harnessed. To our plant from production, we'll start here first, and then here it's pH adjusted, and it's allowed to acidify, so it makes it more favorable for the anaerobic system to work. After here, it splits, so we can either divert to our traditional aerobic process wastewater system, or we can send it through anaerobic. And that we wanted to do just in case a slug load came from production, we could divert, but also once the wastewater that goes through anaerobic hits the aerobic system, it's a little nutrient deficient. So we do need to side stream a little bit just to keep the organisms in the aerobic system alive and happy.
Over time, all of it will go through.
So at full capacity, the anaerobic system will actually only treat about 80% of our wastewater. And that's, like I said, to keep that nutrient demand downstream sufficient.
How many days of storage does this tank give you?
It's about a day.
Okay.
So it's really just a equalization point, just a little bit of time to get the acidification process going. But it's by no means storage in the plant. So that's why we do have a lot of the online monitoring, a lot of the checks, because what might not affect our traditional system could possibly affect this.
So after it runs through here, do you have to do more adjustments then with pH, or does it come out the same as it went in?
It comes out about the same as it went in. There's not much of a change. So the wastewater from here will go to our aerobic system, and the aerobic system will treat it further, and then we'll either irrigate it on the farmland that we have, or we'll send it to Franklin County to their POTW. But the biogas from here, it's captured off the top, and it goes through this unit. It's called the thiopack. And the biogas, it does have a lot of methane in it, but it also has hydrogen sulfide gas. And that's toxic to humans, and it's also corrosive to our equipment. So we want to remove that sulfur from the gas stream. So that's what this system does. It's another small kind of biological reactor.
What do you do with that?
We take that sulfur sludge and just bleed it into our aerobic system, and there, once it hits oxygen, it just kind of dies, and it's broken down further. It goes ups and downs out a little bit. And after the buffer tank, there's one of two directions the gas can flow. If we're producing more biogas than the boilers can handle, we can send it to the flare. And so that, we're expecting, is going to be a regular event. So flame at this site is good right here. Or it can go through a gas conditioning step. So the boilers need pressure, and then they don't like wet gas. So the gas conditioning skid removes some moisture, and it just condenses the gas so that it can then be sent up to our boiler room and used to produce steam for use in production.